Okay, well, good afternoon. My name is Chris Evans. I work on security at Google. And this is a talk today about building security teams. So the chances are, if you want to do security at scale, you're going to want to have a security team that either you scale up the size of it or you scale up the efficiency of it. A little bit about me. The relevant pieces here, to give you an idea of the viewpoint I'm coming from in this talk, is that I founded the Chrome security team in 2009. And a lot of this talk is going to be about the experiences we've had with that security team. We did things a bit differently, we think, and we're going to share those things with you in the hope that you might want to do some of those things yourself. We're also going to look at some of the things that we think went well because of the things we did differently. So I don't want to depress us all on the third slide of this talk, but if you think about it, being a security team is kind of hard, right? So if we look at these anonymized statistics here that are not entirely a million miles away from what I do. Let's say we have a 1,000 employee organization, and let's say that in that organization we have a 20-person security team. That's like 2%. That's actually double what is industry best practice. I forgot the reference, but I think it was the Digital BSIM paper that cited 1% as the sort of standard, the amount to strive for. So this is a well-staffed security team by standards. But if you sort of just do some simple math on that, you're looking at one security team member handling the output of 50 engineers, just as a statistic. And I think that's kind of, I don't know, I think that's a lot of work for just one per security person. And that's if you're doing quite well on the size of your team. So maybe what we want to do is we want to look at ways to scale out the effectiveness of the 20 people or 10 people or 2 people that you do have so that you get more per person. So this talk actually is a sort of a refresh on the talk I did previously called Security Team 2.0. And my original hypothesis was that some of the successes we've had are because of the different way we're structured. But I thought about it relative to the security at scale theme. And the hypothesis is now that some of the successes come from the fact that some of the things we've done differently enabled us to scale up and out. Oh, and of course that means that more effectiveness per person in the team. And just so that we're on the same page regarding definitions, when I say scaling up here, I'm talking about making individuals on the team more productive. When I say scaling out, I'm talking about getting more individuals beyond the core security team involved in the security of whatever you're trying to secure. So we're going to go straight into some of the differences because there's a lot we want to get through today. So this guy here with a necktie, he represents a sort of more traditional security team member. Perhaps he's a little bit corporate. Because of the necktie there. Fortunately, I'm not seeing too many neckties here, so perhaps I'm already preaching to the choir. But anyway, so the first difference is called fix it yourself. And what we look at what the sort of traditional corporate security team member might do, and he's sort of more of a consultant. His role maybe is weighted more towards being an analyst than actually being an engineer. So he may be a pure security guy as opposed to an engineer who happens to have passion in security. And that sort of individual may not be involved in fixing things directly since he's just a consultant to the actual engineering team. So let's look at what we did differently. So as you can see, to be a Chrome security engineer, we've lost the necktie and we've adopted a generally sunny disposition. And what we're going to do is we're going to fix it ourselves. So this is what we do in Chrome security. So we're actually hosted as an organization underneath the Chrome engineering organization. So if you look at the management chain, we report into the directors and the VPs that are responsible for Chrome security. And we're actually part of the organization, and along with that, we have all of the emotional investment in the product that brings. So we're not just sort of consulting off to the side. So when a bug comes in, our team will jump on it and maybe even fix it ourselves without even bothering the engineer whose code it's in. We really are engineers first and foremost, and with a passion for security on the side. And the scaling opportunity here is that we found that if you structure things this way, a really significant feedback loop develops. So we found that if a bug comes in and we fix it, the engineer whose bug it was is kind of really happy that we've done their job for them. And so later when something really serious comes in and it's a bit much for us to deal with, we can call on people and they'll sort of flock to help us because we've been so helpful to them in the past. So that's a minor scale out factor. We also find that structuring things this way, each individual in the team scales up. By diving in and changing the code themselves, they learn about the code And that sort of is a feedback loop. Sort of while fixing things, they'll notice other bugs on the side and sort of fix those too. So individuals really get more productive by structuring things this way. So the second thing we've done differently is we celebrate the community in Chromium security. This is something that the Facebook also does very well. So that traditionally, the sort of more corporate, old school way of doing security, if you get a security report sent to you, your initial response might be to sue the researcher that sent it to you, even if it was disclosed in non-adversarial conditions. You may attempt to vilify people who send things to you. And generally perhaps a lack of enthusiasm to receive any reports from the community, and so on and so forth. So this is how we've done things. And basically, when we get something in, we want to celebrate that community involvement as widely as possible. So there's a laundry list here of things we do. Of the more significant of these, the fact that we have a financial reward per security report is quite significant. That's something that a lot of companies are doing now. We try and also, some people aren't motivated primarily by money. Some people like to share the work they've done, and we really encourage sharing of the more excellent pieces of work that come in. So sometimes when the researcher sends us an awesome piece of work and they're too lazy to write it up for their own blog, we've written it up for them and put it on our blog and sort of really say this is awesome, you should look at this. And we really find that celebrating the community is an unrivaled win for scaling out. If you think about our 20 engineers that we have on our security team, we can get a lot done, but if you imagine that there are probably thousands of really creative minds that are looking over our code and looking for bugs in our code base day in, day out, because of the incentive structure we've set up, how can 20 people in our core security team compete with thousands of people in the wider security community? And it's not just about volume of bugs, it's also about the range of creative thought you get from scaling out to the wider community. We've received bug reports that we'd never have thought to look in at a given area ourselves, or we'd never have thought to put a couple of things together in a clever way ourselves. So this is a huge win if you want to scale out. Just to drop into some figures to underline the success we think that doing these sorts of things has. So across all of Google, our total reward payout for the financial side of the incentive is across $2 million. That's 1 million plus from just Chrome alone, and that maps to about 2,000 plus bugs. And sometimes we, over lunch, we do some idle thought exercises about how many engineers it would have taken to find that same range of 2,000 bugs, and it's a lot more than 20. This graph is always interesting. Just a sort of caveat before you try and scale out to the community. Given that the wider security community is many more people than just your core security team, you're going to get a bit of a bump in issues reported. So this, unfortunately, the vertical axis is not labeled here, but this you can see the relative spike here. So this is the Google Web program, and the sort of small number of samples down at the bottom left is the rate of bugs that were incoming from external before we launched the program. And the day we launched, the floodgates opened, and that spike was it's as steep as it seems. It was literally overnight that we were flooded, and that with reports, and that was a 10 times. I think one of the slides actually listed out. Yeah, that was actually a full-on 10 times spike in incoming load. Fortunately, we sat in a war room and we had bets on how big the spike would be, and I thought maybe we'd get 3 or 4 more bugs in the first day. I did not win that particular sweepstake. Eventually, that initial spike settled to about a drop to a 5 times load, and then settled again later. If we go back to this graph here, you can see it sort of decaying over time. We think that the overall load is now settled to a 3 times load relative to how things were before we launched this program. But this increase is good. This is 3 times more bugs that we get to fix, and a lot more, less bugs for attackers to come and try and take advantage of. And just one graph. Sorry about the sort of change of slide background. I've just sort of doing a bit of mixing and matching here, but this shows another launch that we did. This is the Chromium security reward program that we launched. As you can see, the ramp up here after launch is much more gradual. And we attribute that to the fact that Chrome is a client-side product, and it takes a bit more setup and learning and understanding to sort of dive in and find bugs in a web browser than it does to start banging on a website and finding XSS. But still, over time, the increase in load was probably like 3 to 5 times. And just to underline the creativity aspect that I mentioned earlier of all of these new minds working on your software. I mean, one of our engineers, would they have thought to try this attack? No, we actually had not tried that attack until it was reported immediately upon launch of the reward program, and it's quite a serious bug. You can see that the bug is the the serious security bug is that it really did at the time sound like a real helicopter, which I think has changed since. But obviously we put the crack team on fixing that one right away because of the severe risk involved to all of our users. So here, onto another difference. This is not so much a difference as a sort of philosophical statement, but in Chrome security, we believe that security is not a zero-sum game. Of course, meaning that you don't have to win, you don't have to defeat others to win. So it's sort of a call to collaborate, really. And that's something that traditional companies may not do in the security realm. They see security as sort of something to be minimized and not talked about, and they get the PR team involved at the slightest hint that there might be someone talking about security. And such companies may even discourage collaboration, or at least filter it. But there's a different way of doing things. So working on Chrome security, or even Google in general, we really encourage people to reach out and work with as wide a range of people as possible. We believe that if we all get together as a community and work together, then we all sort of a rising tide lifts all the boats together. So we really encourage people to reach out, and there are various ways we do that. We have various people on standards committees. Even to extreme lengths, we actively support on work time people looking at other products if they want to spend an idle afternoon doing something a little bit different. Just to underline that with a data point, Mozilla also are very good about having this sort of philosophy. So one of the Mozilla employees is one of the top reporters on the Chrome Security Rewards program. He's very good at fuzzing JavaScript. One of the people that used to report to me is the top reporter in terms of monetary value received on the Mozilla Security Rewards program. So there's really awesome cross-pollination of effort going on there. And this is obviously a big scale out. The more you sort of collaborate and share and build a common knowledge base and so on, you're really sort of scaling out so that you're all working on the same problems and putting your weight behind fixing the same problems. So this is kind of a big one, in my opinion. So in Chrome security, we have this, oh, damn, that's my fault kind of mentality. So a bug comes in, and if it might feasibly affect any of our users, we don't care whose fault it is. We don't finger point and say, oh, that's a bug in plugin vendor X, or plugin vendor Y, or operating system vendor, whatever. We just say, yeah, thank you, this is a risk to our users. What we're going to do is we're going to treat it with the same severity and urgency as if it were a bug in our own code. Of course, the traditional team does not do that. They're actually quite relieved when a bug comes in and it's not their responsibility at all. They can drop it like a hot potato and hunker down behind the PR people who can say it's not our fault and so on. That's not what we like to do. So just some bullet points there that illustrate how thoroughly we take this principle. Third-party code, if it's open sourced or closed sourced, if there's a bug in it that might affect our users feasibly, we treat it as our own fault. There are some historical user experience problems in browsers, and everyone sort of hides behind the defense that, well, the user experience is the same across all browsers, so we're okay, right? We don't think that's the case. We're trying to staff up a UX team. We're interested in bugs in plugins, in operating system kernels, and sandbox escapes, and it's all our fault. And we think this is a scale up here. We've thought about this, and we think it's a scale up because what happens is if everything is in scope for our people on our team to work on, then what they'll do is they naturally gravitate like people do, the good people do. They naturally gravitate towards fixing the most serious problems, the problems which represent the biggest threat to end user security. And quite often, if your own security posture is quite mature, you might find that you run the numbers, so to speak, and debate it out, and you think, well, the biggest threat to user security might be some plugin, and then engineers would drift over to that, and by working on that threat that's not necessarily your fault, they'll actually have a lot more impact on end user security. So we're quite happy with how this is working out, and we sort of apply this not just to our own engineers, but we also do things like reward under our reward program, which we covered just now. We've issued rewards for bugs in code that's not ours, so we're trying to scale up the people that we've previously scaled out as well, if that makes sense. Transparency. To an extent on Chrome security, we have a slightly unfair advantage here because we're fundamentally an open source project, and that means that we're transparent in that our source is readily available, and that's not something that it's hard to fault the corporate guy here if they're fundamentally working on a closed source project. But there are other ways to be transparent even if you are closed source, and we find that a lot of the opportunities that we've taken we don't think have been necessarily taken widely across the industry. So the old school way of doing things is that you don't, when a researcher comes to you and gives you wants to talk about a bug and collaborate, they don't necessarily give forthcoming responses and engage in open dialogue. Maybe there's a PR concern that the whole dialogue may be posted to the internet, and that does happen. If you find bugs internally, then that's something that can, excellent, it's been found internally, not externally, we can sweep it under the carpet. We see quite a lot of that. We don't think that's necessarily the right thing to do for end user security. And the general default to secrecy in this more traditional security team. That's not how we like to do things. So we kind of like the fact that all security bugs are tracked in our public bug tracker. And that includes internal finds, and all bugs at some stage, unless there's some pressing need to keep something highly confidential, all bugs by default will be opened up to the public at some later date. And that means that the full history of the report will become available, and that's quite cool because we think of each report not as necessarily a bug report, but as a conversation that's occurred between us and the researcher. And sometimes you can see back and forth and so on, and there's quite some historical splunking to be done here if you're into that sort of thing. I don't think we have time to go into it, but there's a story sort of alluded to here where, because of the openness and the two-way conversation we had going between us and the researcher, we actually committed a fix very quickly after the researcher sent us a report. Because we're an open source project, the researcher looked at the code change and said, I don't think you've fully covered everything you need to fix. And we looked at it and we said, oh yes, you're right, thank you, that's actually true, and we're going to double your reward, going back to our celebrate the community principle. And it all worked out very well, we think, and transparency was one of the root causes there. And just a quick story, we had a minor incident, and we can link the transparency that we have back to successfully dealing with that incident, we think. So we catalyzed a rage in someone unknown to us by doing a public blog post in Google stating some political opinion on how companies should react to a zero-day bug that's in the wild, known to be in the wild, and exploited, and so on. Without getting into that actual blog post, someone read it and were enraged, as of course is their right to be, and they responded by posting a blog post that said that there were tons of critical Chrome security vulnerabilities they'd reported to us, and we hadn't fixed them, so we were negligent according to our own standards. Now this had the potential to be quite a PR flap, we think, if we didn't have any solid information to counter it hurriedly, because the press does love to run with the stories where the big guy is being a pain in the ass. So fortunately, we're able to quickly look into this, find the bugs in question that were mentioned as unfixed in the blog post, and since they're all open because of the openness of our bug tracker, we're able to create a link, and there it is, which sort of with just a link searched for and documented all of the bugs in a list, and publish that link and say, yeah, well, go and make your own conclusions. And people did, I suppose, because the story died out pretty quickly. the original blog post was edited within an hour or two of being published. And perhaps the most amusing part of this story is that when we went back and looked at the historical reports from this individual, we noticed that one of the bugs reported, he'd actually uploaded to the bug report as an attachment a copy of his local profile within which were contained cookies to internal logins to the company involved. So, as a favor, we very quickly scrubbed that because that was out there in the public. For, not as cookies, also passwords, I think. He just uploaded a zip of some directory on his drive, which had all sorts of sensitive things in there. So we sanitized that fairly quickly, and the story blew over. And transparency really helped us just sort of respond with a minimum of fuss. So that was a scale up. Instead of having to get into some big PR flap, we just publish, I think via Twitter, a link, and that was job done. So that saved a lot of time. We think there's a lot of scale out opportunities here. If you go and search for a bug tracker, there's a real gold mine of information. Like some of the competitions we run encourage people to try and create full exploits against Chrome. Those are publicly visible now, obviously fixed a long time ago, publicly visible as attachments in the bug tracker. So if you want to go and learn from the skills and exploits of others, you can go and look at those too. So it's time for another difference. We believe in removing the middleman. So the next diagram we're about to see is my attempt to recreate the process that must be going on inside a large corporation that I've done security business with, if you like, in the past. So I tried to recreate the flowchart of what I think is going on, but so let's see. So start here is me emailing them, and then an automated reply straight away saying, hey, we're going to look at this, awesome. And then internally, some dialogues going on between the sort of security response team and sort of pinging over questions to the security engineering team, who may need to then bring in a third team of security experts if it's a tricky issue, and then PR get involved, and then some back and forth may occur, but of course you're not talking directly with the most technical person who understands the bug you've reported the best, so you might get some lost in translations and so on. Problems that you see as the sort of external observer to this flowchart are, there's a lot of latency in the communication going on. When you do get a response, sometimes it doesn't necessarily make sense. Maybe it feels like it's been authored by someone who's not the most technical person. Maybe it feels like it's also been filtered through, lawyers and PR and so on. And so it's hard to have discussions in this forum. So the way we've done things, we've removed the middleman. So when you report a bug against Chrome, you just file a bug in the bug tracker. And if it's a security bug, the relevant people get auto-CC'd, like the security team members. And usually the same day, some form of conversation kicks off, and up to 3 people or more involved. But you can get the person who reported the bug talking directly to the engineer who's going to fix the bug, with ask the security team advising on the side, and you can see people responding in real time. We CC in more experts as required. Some of the effects here are that the latency is really low. We've done some same-day fixes. It's happened on several occasions. Quite often we resolve things quickly enough that people say, wow, that was really fast, and we really enjoyed when getting feedback like that. And doing things this way, we feel is a massive productivity boost because of the speed of which the iteration is going on, and so that's a scale up. So just looking at the time, I thought we were going to be slower than this. So there's a story here we'll go into since we have the time. So this is a story about going the extra mile. So if you look at these phrases here, and if you Google them, quotes and all, you'll find that these are really common phrases to find on corporate websites describing security posture. We take security very seriously, and it's one of our top priorities, and we designed everything with security in mind. Of course, what else are you going to say? Security is priority 5 out of 7 or something. We didn't give a stuff about security when we designed this. We just shoehorned it out the door. So you have to say these things. So everyone talks the talk. But we believe in walking the walk, we think that. we think that one of the ways we walk the walk is we go the extra mile, and we have some stories that we think illustrate the sort of going the extra mile that we get into. So traditionally, you might find that non-security concerns outweigh security concerns, as in various engineering teams have veto power on what security team want to do. It's kind of annoying, and you may have you may even be banned from fixing something due to legacy concerns. No one's interested in breaking anything. So legacy is allowed to impede the progress of security, very tedious. We try and go the extra mile. So we don't shy away from changes in behavior if it's the right thing to do for user security. We've covered that we tackle others' problems for them. So if we see a bug come in against someone else's code, we'll try and get them to fix it, and often then loan them some resources to help them improve their security, as we covered earlier. When we find a bug internally, we treat it with equal severity as if it had come in externally, if that makes sense. So no sweeping something under the carpet. So we see every security bug as a potential disaster. You don't know which security bug an attacker is going to come at you with. They don't exclusively limit themselves to externally reported bugs. They might come after you with an internally reported bug. So what we do is we backport those as aggressively as we do the externally reported bugs. Just a sort of brief aside into a personal rant of mine, if you like, but on the backporting of internal fines, not all companies do this, and it annoys me. The reason is that the security industry is kind of changing, and there's this comic that was published, I think, last year or maybe the year before even now, or a series of comics by some people in the security industry who are quite well connected about how things are going, and this comic struck a particular note with me. And I don't know if you can read it from where you are, but the gist of this comic is that whenever you find a bug, either because you found it internally with your own security team or some external reporter sent it to you, you or the external researcher, you were not the first person to find that bug. The chances of you or the external researcher being the first person to find that bug are pretty low, we think, in the modern security scene. And the other people that have found this bug, statistically, other people have found this bug, and they haven't told anyone about it, and there's a reason for that, and it's not good news. So that's why we like to go the extra mile in treating every bug, even the internal fines, as serious. So here's just a fun little story, or at least I think it's fun. Hopefully you'll find it fun too and not boring, of us going the extra mile. Switch of slide background again, sorry again. So back to 2011, but this company called VUPEN, who are a security research outfit, non-disclosed a bug to us. I mean, what the hell does that mean? It means they sort of trumpeted from the hills the fact that they had a bug in our software, but declined to provide any details of what it might be or any evidence to back up their claim. They did disclose it via a YouTube video, as is popular to do. Normally, disclosure via YouTube video indicates a very low quality of bug, but this, and if it's a YouTube video with a techno track as the background, you just know that it's a really really tedious bug, and you're going to spend days going back and forth anyway. But this is an exception. This YouTube video, did show an actual serious bug. We may not like the business model of the company involved here, but they know what they're doing, and when they say they have something, they don't lie about it. So we have this video, and it says there's a serious bug in Chrome, and that's it. I mean, what can we do? Our assertion is that a normal security team would just say, well, this is completely unverifiable, and just ignore it. I'll probably call the PR people up and say, hey, can you just deal with this? Nothing we can do about it. But we thought, well, actually, maybe there is something we can do about this. So we played the video forwards, backwards, up, down, left, right, whichever way, several times, and we arrived at this freeze frame in the video. As you can see, all that's going on here is that there's a browser running, it's Chrome, and eventually, after visiting some internally IP'd website, a calculator pops up, standard fare for showing that you've exploited a browser. And they have a process explorer up in the background. That's to illustrate the integrity of the calculator that pops up to prove that they've thoroughly compromised all the sandbox and so on. So, I mean, still can't do anything, right? Or so we thought. So, there's a bit of a zoom in here. From just the little Chrome icon here in the bottom in the task manager, nothing exciting there, it's just showing that Chrome's running. However, if you zoom in just above the Chrome icon, there's 2 pixels deep of another icon showing. It just so happens that it's a fairly unique signature in terms of icons that might run as a child process within Chrome. It indicates, specifically at the time, that indicated that the Flash plugin had loaded. Now that's an information leak. And from some of the best in the business. Obviously, the people on the grey side of the industry are quite quiet about these sorts of things. They didn't reflect back to us how irritated they were about their mistake. But we assume they must have been a bit irritated by that one. So of course, these are the best in the business. Surely that was the only mistake they could have possibly made in this one single freeze frame. No. So this is kind of interesting. If you look at the integrity levels and number of processes here, it also is strong evidence that the Flash plugin is launched. Now, at a first glance, that's not a match, but it happens to be that there's a bug in the Process Explorer that comes with Windows running in the background, where it mislabels the integrity of a process under certain conditions. Unfortunately, one of our engineers knew of that quirk and was able to, keep us on track there. So, of course, that was the last. Nope, there's another leak right here, and this is the size of one of the Google Chrome processors. It's about it's approaching 0.5 gigabyte in size. That tells us that the technique that they're using here involves some form of spray, and that's useful information to us because we can go and add some defenses against the attack, knowing that that's what attackers like to use. We subsequently did. We broke a lot of sites using Flash in the process, but that's another story. I had to roll it back and so on. So that oh no, there's one more leak in this single freeze frame, and that's the fact that there are these scroll bars here, despite the fact that the content's just one sentence. And that indicates that there's an invisible, that correlates with the default plugin size if you just load a plugin but don't render anything in it, So if you sort of map the size of that window to the size of a default plugin rectangle, I think we worked out that that's the scroll bar situation you would see. So definitely a plugin attack. Bug in Flash, not our bug. But unfortunately, one of the earlier principles we covered is that it's all our fault. So we have to do something about this because that's our culture. So. Okay, so what do we do? So we have this engineer on staff, name of Tavis. Hands up if you've heard of Tavis.
I used to work at Sophos.
I'm so sorry. That was about 50%. Anyway, he's really good. So we said, Tavis, Flash, please, yes, go. He decided to pair his intelligence with the scale at which Google operates. So he, what did he do? I forget, that's the story here. He used the Google index to look at every Flash file publicly in existence. All of them. And I don't know why I don't have the stats here. I thought the number of terabytes involved is many. If I remember, I'll let you know. But many terabytes of Flash files. I sort of did some magic on them to sort of reduce them to a set of Flash files that represents a minimal set of Flash files representing the full code coverage achievable with the full set. Quite computationally expensive. So I think I can't remember if this is a story or not, but Tavis comes to me from time to time and says, "Can I have a few machines?" And I said, "How many would you like, Tavis?" And he wanted 100, so I gave him 2,000 to get the job done quicker. So of all of the Flash files on the internet, this process sort of crunched them down to 20,000 files, which represented a manageable test set with which to do some security testing that got the code coverage represented by all Flash on the internet. So they then cranked across those 20,000 files with some standard fuzzing techniques and got 100 distinct nasty-looking security bugs out. I think Adobe whittled it down to 70 and got those pushed to get those fixed in a reasonable time frame, which they were. And we did get some unofficial feedback from the grey side of the community that we'd massacred quite a large number of vulnerabilities that were out there. So that's good, not just for us, but for the whole internet. That's another principle we have. We like it when we make everyone safer, not just ourselves. In addition, we tightened up the Flash sandbox just in case the VUPEN bug was the 101st bug out of the 100 that we found. Eventually, we did get formal confirmation via various sources that we got the bug that was being used and the sandbox escape that was being used. It was also a flash problem. This incident caused us to accelerate work on something called Pepper Flash, which is a much more robust sandbox for Flash that we now have in Chrome. We went on what I call a rampage for Flash JIT spray protection. I mentioned that we, in our eagerness to tighten things up here, we kind of overstepped the mark a little bit. So the engineer that tightened things up here put a little signature in so that if his protection ever triggered, it would pop up this dialog box to say, hey, stop trying to mess around, hey. And it was supposed to only ever pop up when the user was under attack. Unfortunately, it had a propensity to pop up when the user was playing Zynga games. So, with perhaps even more unfortunately, the string he chose to use to denote that this protection had fired, of course, was a bad idea. So there were these Zynga game players, confused that we were, giving a strong opinion to them that it was a bad idea that they were playing Zynga games with this dialog box popping up all the time. So we had to back off a bit there. I guess we moved fast and broke things, actually. No, this was done in a hurry, and we broke things. So, success, I suppose. And we further invited the community to Rampage. Based on this, we said, hey, if you find bugs in any plugin of significance to our users, we'll consider that under our security rewards program. So this is sort of the alternative ending if we didn't have time to go into the story, which we did. So, but it's just to say that one of the ways we scale is we scale using actual machine resource scale, and we think that's if you have a ton of machines at your disposal, you can scale up. So when say an external researcher reports a security bug to us, we can throw that into our automated system and have it automatically determine some of the properties of the bug that's been sent to us. That's scaling up by making each individual more productive by providing automation, and of course scaling out. When you have a fuzzer, you can run it across 2,000 machines. It'll find a lot more bugs than just running it on a few machines. And furthermore, we sort of combined this type of scale with some of our other principles, like involving the community, and we actually, under certain circumstances, invite the community to have access to our scale so that they can be more effective in working with us to find bugs, and that's something we're quite pleased with. And with that, it's time for Q&A. I think we had a hand here at the front.
Thanks for the talk. This is very interesting. So the first question is that it's great that you encourage community to contribute. But do you have a similar program in place to encourage regular developers to take security seriously? Some kind of incentive program to encourage internal developers? Oh, yes,
of course. So one thing that we do mention prominently in the talks we do that are more specifically about the bug bounty program is that we don't see this as a replacement for security practices internally. It's kind of a cherry on top of mature STL, where internally you have a lot of programs that try and do a good faith effort to find the bugs before they're released and the community finds them. I'm not sure if that answers your question. Did I miss what you were asking?
Could you repeat your answer a little bit, elaborate a little more?
Yeah, and which bit would you like?
So you're saying that the award applied to the internal employees as well? Is that?
Oh no, we don't actually pay people internally. I mean, there's potential conflict of interest there, and it's kind of people's paid jobs to not do these bugs in the first place, right?
Yeah.
So,
and it's interesting that you mentioned that you invite the communities to run the fuzzing too. How do you do that? Do you allow them to send requests directly to Google, or can you elaborate on that?
That's a good question. So the question is, how does external contributors providing fuzzers to us work? Yeah. So the way it tends to work is for the researchers where we have a good relationship with, we trust them, we sort of know them, we've worked with them very productively. For trusted people, we sort of invite them to send us their fuzzer code. It's quite a compelling approach. We say, hey, you've got $10,000 from this fuzzer so far running on your your mom's machine in the basement. Would you like us to run it for you on 2,000 machines? And what we'll do is we'll track and tag anything that gets found at that scale and pay you as if you had done it yourself. And it's a real win-win, we think. They get more money, we get more bugs, and users are safer. So that works pretty well. The only caveat I would add is we make sure the fuzzers are simple so that we can code review them obviously before we go and throw them into our infrastructure.
Sure. Yeah. The last question, it may be a little bit off topic. If so, please let me know and we can talk offline. I'm interested in learning a bit more about what do you do in regards to the security of plugins, the Chrome plugins. Do you allow people to report bugs on plugins, or you mean like Chrome plugins? Yeah.
By a Chrome plugin, what do you mean? Do you mean the plugins that we ship with Chrome, or do you mean the plugins that just sort of run in the browser?
Run in the browser, like you can download from Chrome.
Okay.
Yeah, Chrome.
What do we do about plugins? Yeah. So where possible now, we started blocking them by default. That's the first thing we've done. So Java, which has been in the news from time to time for the past year or two, we've actually had that blocked so that a user has to click and authorize to run it for a few years now. So the first thing we're doing was just sort of looking at the plugins that represent a lot of risk and trying to disable so-called drive-by attacks, so the user at least sees that the plugin attempts to run. That's had some success, we think. In terms of if people send us a bug in some of the plugins we ship with Chrome, we'll immediately send the bug to the actual person who might be able to fix it if we're not able to fix it ourselves. We tag the bug with a piece of metadata, say consider this for a reward, and later on, if the bug turns out to be serious, we'll go and reward it.
So how about extensions? There are a lot of more extensions out there.
Extensions. So we do pay rewards for Google authored extensions under the Google Web program now. I believe that's something that was changed last year sometime. For third-party extensions, we don't yet have a program. It might be prone to one of those things that's prone to abuse as well. But we definitely do have some initiatives that look at the top end plugins, regardless of who wrote them, and try to keep them secure.
Thanks.
I have a question on the web security program. So you illustrated the trends, mentioning, as far as I remember, it's now 3%, like 3 times more than when you first started, but it's less than when you had the spike, right? Do you think it's due to the fact that you killed most of the bugs and developers are not introducing as many bugs as before, or it's because the attention of the community is also focused on other company that in the meantime started bug bounties? Because I feel for a smaller company, it's difficult to attract people for a web, bug bounty program, for example.
That's a good question. Yeah. So why do we think the number of reports tailed off, basically?
Yeah.
So we do talk to all of the top reporters that send bugs to us. If we haven't heard from someone who was previously prolific for a few months, we'll ping them and just ask, hey, what's going on? And we have got robust feedback that it got a lot harder. So and when it gets harder, people doing this, they follow the path of least resistance, right? When one property gets hard, they move on to the next property who are offering bounties, and then that gets hard. So I would suggest that eventually you'll come to the top of that list, right? If everything's getting more solid, eventually you'll be at the top of the list. Also, from time to time, when there are a number of reports to start to drop off, we just bump the prices up. This thing's just one big economy, and you can control it by twiddling this big knob, which is the payout level. We've done that 2 or 3 times in the history of the program now, and every time we do that, we had another little bump of. And eventually, you do that enough times, like we have on the Chrome security side, and you turn the knob, and one day you'll find that nothing happens, and then it's like, oh, what do we do next? But at that point, that it really is quite tricky to find bugs in your software.
Do you pay a bounty for for bugs that there's no obvious security law in, just to encourage people to report all bugs?
Do we pay bounties for non-security bugs? No.
Okay. And just as a comment, I really like what you guys are doing. And as I said, Tavis Ramundi kicked my old employer in the pants, found a whole bunch of bugs with our security products, and forced us to deal with them in a stronger way. And this was because we criticized his imminent release of someone else's bugs. We said, oh, don't do that. Give that company tons of time. He turned around, he did this to us, showed that that ton of time was almost entirely eaten up by lawyers, by nonsense. By the time it got to the engineers, we had a week or two to fix something and throw it out the door. So I really think that that extra time is a joke, and I'm glad you're showing the world that people can turn around fairly large fixes in a couple days to probably the most used application on the planet.
Thank you.
Anyone else need a mic?
So you said you release all the, or you publish all the reports pretty early. Isn't there a risk of black hats abusing them to attack users who haven't updated their browsers yet?
Good question. So by releasing to the public security bugs, is there a risk there? So one of the things that works best in the Chromium security story is the automatic update. And we have graphs that sort of demonstrate that when we push a new release out with security fixes, you can sort of see the population of the older versions sort of crash to the floor over a small number of days, and the population of the new fixed browser sort of tend towards 100% pretty quickly. So the risk there is, and we don't do it immediately. We do have a some number of days or weeks delay, and it's kind of random depending on when someone gets to it, right? So we think we're covered there. The thing that we worry about more is where we have shared code bases with other people. Like for a long time, we were based on WebKit, which is the rendering engine shared with Apple, Safari, and Safari Mobile. And obviously, mobile devices have a much sort of longer update cycle in terms of getting bug fixed sometimes. So we did try to sort of not release things that would put other vendors and other users at risk with shared code bases as well. Although we didn't really, I suppose we didn't have anything formal there. We just sort of, wait a few months and that should be good enough. I don't know if that answers your question.
Cool. Anyone else? I'm just wondering how many Pinkie Pie figures do you guys have in your desktops, if any?
Question about Pinkie Pie, of course, one of the most prolific exploit writers against Chrome. He's banked hundreds of thousands of dollars in across various high-profile competitions. We do actually have printouts of Pinkie Pie, the pony around the office, just to remind us that there are some very skilled people out there.
Get my exercise today.
You mentioned Chrome browser updates, right? But I think Chrome is also available on the Android device now. How does it update automatically, or does the user have to choose to upgrade?
The question is Chrome on Android updates. I believe it does automatically update on latest Android devices too. An exception would be if a new permission was asked for, in which case then the user has to accept the update. But generally, it's a browser. It has all permissions already, so it'll automatically update.
Have you moved any of the Chrome code into the Google code that gets updated not as part of the distro? Are you familiar with what I mean? There are libraries that used to be updated only when you went from Jelly Bean to, and now they're pushed out as sort of Google services, I think, is that what it's called? Have you moved any part of Chrome into that to make it more auto-updating so the user doesn't?
So a disclaimer, I'm not overly familiar with the Android side of the things by choice. Yeah, I don't have the answer to that. I'll think about it and we'll catch up if I think of an answer.
Yeah. What's like the? You said I'm here. Hit a line. So you said you receive a lot of not security bugs, a lot of funny bugs. What's like the signal to noise ratio, and what type of efforts do you take to filter out the noise? Because we see a lot of noise more than signals in terms of the bugs, and we're not sure how to attract the good ones.
Signal to noise ratio, yeah. So of the two reward programs we have, the Chromium reward program has an okay signal to noise ratio. Not entirely sure why, but the web program has a fairly poor signal to noise ratio, and we actually call it the crap gap. It's the sort of ratio, the number of reports that come in of those, the number that are rubbish versus the number where there's some real value. That ratio is changing, and it's not changing in the positive direction, unfortunately. So the way we've responded to that is we've tried to get more automation into the process. So when someone comes to a sort of bug, they're sort of faced with more automatic forms that try and discern whether they know what they're talking about or not. With the internal UIs to sort of quickly triage a bug as rubbish have been streamlined so that if a bug's clearly just nonsense, it's just a one-button click to try and lower the overhead for the individual doing the triage. So we think we're keeping our head above water with some measures like that. It's not yet at a disastrous level.
Similar question about the noise that you get from researchers. Do you find with the web stuff that a lot of people report bugs in Google properties, quote unquote, that are not actually your properties? Yes. There's something called google-store.com where you can buy Google branded stuff. And it's not operated by us, but it has a few bugs in it. If you wanted to go and start typing on your keyboards now, you could probably find some by the time we're finished. So yes, anything with the word Google in the DNS name, people seem to think we own it, and so we do get a lot of bugs that don't belong to us. Of course, we just immediately forward it on to the person we best think does own that bug. Okay, I'll repeat that one because the microphone wasn't working. So how do we behave with mergers and acquisitions? So if you have a reasonably mature security team, like we believe we do, when you acquire someone, it's often the case that the security of the acquired company isn't quite up to the same standard that you hold yourself to. And one of the first things in the onboarding process is trying to raise that standard. But that takes time. So what we do regarding the reward program is when we acquire something, we have a 6-month exclusion where we say we want to take 6 months to try and panel beat this acquisition into shape. And after those 6 months, have at it. And if we've taken more than 6 months to beat it into shape, that's our bad. Have at it, and we'll reward you under our standard program if you find bugs.
All right. Thanks a lot, Chris.